speak to you today on behalf of the League of Women Voters and the Seymour Marine Discovery Center. I'm a member of both, in fact, a founding member of Seymour Marine Discovery Center, and I'm delighted to see such a large group of people, and thank you for coming today. My name is Barbara Lewis. I'm the president currently of the League of Women Voters, and I have been asked to announce that if you want to go through Seymour Marine Discovery Center, which has some great exhibits, they do expect you to pay an admission charge. Unless you're a member or a guest of a member and have a member guest pass.
But it's worth it.
It is great. This is a place to come many times. And many of you I know have been here before. I would also like to call our attention to our membership chair, Peggy Marcatello, who's standing up over there with some League of Women Voters membership brochures. And she will be happy to give as many as we have a demand for out, and she will take your contact information out otherwise. And we do have a website. Jan Carwin, our website administrator, is here. And so if we run out of information, the website, lwvscc.org, is available, or you can just Google League of Women Voters of Santa Cruz County. The League of Women Voters has been at the forefront of environmental protection movements. I think many of you may not be aware of that. We're known for candidates forums and other types of activities. One of our speakers today, Dr. Mike Orbach, is a member of the League of Women Voters, as is my husband, Bob. And you may not be aware that we have family memberships and that there are many men in the League of Women Voters. At the state convention, they're quite vocal, I feel advocating for things. And I would like to also say that we have had a wonderful response from the Seymour Marine Discovery Center people. I would like to thank them for agreeing to tape this program, for setting up the equipment for us as a donation. They're not billing the League of Women Voters, and for opening this room, which is an ample-sized room, and they've been a pleasure to deal with. I'm not biased just because I'm a founding member of the Seymour Marine Discovery Center, but I do think it's a wonderful place. Our first speaker is Dr. Gary Griggs, and he is so well known in our community that he scarcely needs an introduction. He told me to not say too much about him because that keeps the level of expectation low for his talk. But I should mention that he has been a professor at UCSC and that he was the first faculty member with expertise in oceanography. I thought that was quite interesting, something I didn't know. You're probably familiar with him from his column in the Santa Cruz Sentinel, his books, and the articles he's published I was aware of, but I didn't know the number of articles are in excess of 145, so he's a prolific writer as well as a teacher. For the talk today, Gary Griggs will focus on the biophysical science part of the changing climate and the California coast. Then our second speaker, Dr. Mike Orbach, will talk about the law and policy related to this topic. Mike also said that he would love to have a very short introduction. I didn't want to offend somebody by omitting some important part of their distinguished record, but I will just mention that he is a professor emeritus of marine affairs and policy in the Nichols School of Environment at Duke University, which is in Durham, North Carolina. And he is also currently a family member, as I said, of the League of Women Voters, to his credit. And he has been Associate Director of the Center for Coastal Marine Studies at the University of California, and a Professor of Anthropology at East Carolina University. He joined the Duke Marine Laboratory in 1993 and was Director of the Marine Lab from 1998 to 2006. When I was membership chair of the League, and Mike joined with his wife, Judy, who I should mention is our co-program chair and helped a great deal in setting up this event. I was just delighted because this is one of my favorite subjects, and I was hoping that Mike would sometime speak to us, and he will today. Our today's talk should be about 20 to 25 minutes each, and then we will have a 10 to 20 minute question and answer period. So that is the format. So first, Gary Griggs.
Can people hear me? Okay. Well, I just learned more than I ever knew about the League of Women Voters, and I'm going to have to get rid of all those man jokes I was going to tell. We'll go from there.
No sex change operation required. Enjoy.
It's probably hard to pick up the paper today without reading something about, well, either Donald Trump or climate change. So we're going to try to put as much as we can in the next 45 minutes or so, coming from two slightly different perspectives. This happens to be the Bay Bridge in the Embarcadero. It's not some foreign country, and it's not with any additional sea level rise, but it's at a very high tide today. But if we look around, there are lots of places where we've now gone back into the past to discover climate change. We can go from deep sea drilling, where we've gone back over 100 million years of climate change is recorded. We've now gone into the Antarctic and Greenland ice sheets, where we've gone back 850,000 years. We've looked at things like bristlecone pines that live about 5,000 years at the maximum, and we can tell from tree ring width what climate has been like. We can also look at corals and pollen records. So climate change, climate fluctuations are something we've known about for a long time. We can go back literally tens of millions of years and see how Earth's climate has changed, way before humans came on the scene. And one of the big natural drivers of climate change is natural cycles in the Earth's relationship to the sun, because that's where most of our energy is coming from. And it turns out we don't stay the same distance from the sun, but in fact, the Earth actually wobbles on its axis like a top. And that has a cycle of about 26,000 years, which can take the northern hemisphere a little further away or bring it a little closer. We've got a tilt in our axis of rotation, and that's what gives us the seasons. And that actually changes over several degrees, which affects how far we are from the sun. And then the orbit around the sun is not a circle, but it's an ellipse. So over about 100,000 year cycles, we're closer or further away. And those three cycles all work together to make the Earth's climate change over time. Again, this has been going on ever since we've had an Earth. We know how old the Earth is? Roughly 4.5 billion years. So we've had climate change going on for a long time. And one of the reasons that, in fact, climate has been changing more recently is greenhouse gas emissions, but we've discovered that in some ways from going back into the Antarctic, where we've drilled back now, well, down 11,500 feet, gone back over 800,000 years. One of the things we can measure in the bubbles in the ice is carbon dioxide content. which that is part of precipitation. It gets caught in the snow and the ice pack. So these are these natural fluctuations. In fact, they're tied into those climate changes. That's a slightly more complicated story, but as natural climate changes, greenhouse gas emissions change because permafrost thaws, releases carbon, ocean temperatures change, and gas concentrations fluctuate. What we discovered over about the last century or so is that CO2 levels increased, and if we look at it, the last measurement from a couple of weeks ago, it's gone up now about 34% over this natural record. So that CO2 is going up on a regular basis. In fact, these are some of the possible scenarios for the future that people are very concerned about. And in fact, just cutting this kind of short here, even though you see Priuses in Santa Cruz, we haven't had much effect on the reduction of carbon dioxide. So this is just going back 200 years. This is total CO2 emissions up to about 2000, maybe 10 or 12. And we can see oil, coal, natural gas, and cement production are the main drivers of where all that carbon dioxide is coming from. I think Mike will talk a little about this. Even if we eliminated all that tomorrow, we're not going to change climate instantly. Where is it coming from? 91% from burning fossil fuels and making cement. Actually, making cement is a huge producer of carbon dioxide. Land use change, burning stuff, basically. Where does it go, all that carbon dioxide? Roughly half of it into the atmosphere, roughly a fourth each into vegetation and into the oceans, and that creates some other issues. So what's likely to happen as climate continues to change? And one of the questions I think it's important to look at is what's the difference between weather and climate? People have said climate's what you predict, weather's what you get. So climate tends to be long-term, decades, hundreds, thousands of years. What we see in the short term is weather. This week it's been wetter than normal. The week before that was colder than normal. But we have those fluctuations. And we need to think of the big picture as well as what's happening day to day. So some of the things that all of our observations and all of our models are telling us is temperatures are going to continue to increase. That's going to produce summer water shortages and longer droughts. And it's always tricky to say, is this last 4-year drought due to climate change or not? I think it's easy to say climate change is probably having an impact on it. We can't necessarily blame it all on climate change. We've had definitely long-term droughts in the past that have lasted decades. So that's not out of keeping. But when we look at every year getting warmer than the year before it, or most of the warmest years of the past century all occurring since 2100, we begin to see some patterns. That dryness produces probably more wildland fires. The belief is we're going to have more concentrated winter runoff and therefore more flooding. It seems like it just starts to rain and we start to put out flood warnings. Finally, what we want to focus on today, sea level rise with increased coastal flooding and cliff erosion. So these are not new events. We've seen these happen many, many times in the past, but probably they will happen more often and be more intense. So try to put sea level rise in some perspective. Sea level didn't start rising yesterday, but if we go back, this is just in thousands of years before the present. If we go back roughly 375,000 years ago and come to the present, this is what sea level has done over time. And this is meters below the present. So think of this as about 400 feet below the present. So even though we call sea level 0 today by convention, it's been anywhere but 0. If civilization had evolved back here, we'd all be under 400 feet of water. And in fact, these are those 100,000 year cycles in the climate. And within there are some 40,000 year cycles and 20,000 that are all sort of combined here. But as the Earth has cooled and warmed, sea level has fallen and risen for a couple of reasons. In part, the more ice we melt, the higher sea level gets. That's happening today. And the other is that as the ocean warms, it expands. So the warmer the ocean, the more volume it takes up. It's not political science, it's physical science. just like carbon dioxide does not have political parties. I don't need to tell you that. So, about 20,000 years ago, the last ice age ended, and roughly 3% of all the ocean's water, which was about 10 million cubic miles, was sitting on the continents as ice. Glaciers that covered most of North America, much of the northern latitudes. So all that water came out of the oceans. It lowered sea level about 400 feet. So sea level dropped to about 400 feet below the present 20,000 years ago. When the ice age ended, that ice melted, seawater warmed, and sea level rose to its present level. But you can see, in a normal pattern of things, as we've seen over the last 375,000 years, the next pattern should be sea level begin to drop. It's not doing that. I want to expand on that and say, we know now that this area was all covered with ice 20,000 years ago. Cape Cod is basically the end of the glaciers. Martha's Vineyard, Nantucket are all ice debris left behind. Early humans from North America likely came across a land bridge. Mike may argue that is an anthropologist.
No.
Not today. And if we look at Seattle, if you look at this picture, you'll see Seattle was glaciated. In fact, this is the Space Needle, 600 feet high. Seattle was under 3,000 feet of ice. There was no Starbucks. No Costco did not start glacier. No Microsoft. So that's a lot of ice, and that's all that ocean water. And we had to put it somewhere, and it went off the continents as ice, and we know Puget Sound was glaciated and so forth. So expanding that last roughly 20-some thousand years since the last ice age ended, this is coming from 20,000 years ago to 0 today. So this is where sea level was. It dropped close to 400 feet, and as those ice sheets and glaciers began to melt and the ocean water began to warm, sea level began to rise. You can go into how we know this, but it's not important right now. You just have to believe me. Okay? Take it on faith. Trust me. So we can kind of average out that rise over from 20,000 to maybe 8,000 years ago. So sea level rose at almost a half an inch a year. 45 inches in 100 years. The last century globally it rose maybe 8 inches. So this is a pretty rapid clip. But in that period of average, there is also some pulses. And we think those are when big chunks of glaciers broke off in Antarctica. So it rose as high or as fast as almost an inch a year. Now that may not seem like anything if you're standing out on a dust cliff. Inch doesn't matter. But if you're living in North Carolina or Southeast Asia, Bangladesh, or any place else where
Or downtown Santa Cruz.
where the slope of the land might be, a foot in a mile, a foot or a few inches goes inland hundreds of feet or thousands of feet. So sea level came up very fast. For roughly the last 8,000 years or so, relatively little change. And this is about the period of human civilization. You can argue about it, start 10,000 or what civilization, but through most of our human history, sea level has been constant. It's not any longer. So this is the rate we're seeing now, about a foot per century, but most likely it's going to do that for a bunch of reasons. So we're going to get back to some rates that looks like equivalent to the geologic past. So I mentioned before, where's that coming from at any particular place? Ice melt, we think, is about 2/3 of that rise. Expansion of water, maybe a third of that. And then depending on where we are around the world, whether the land is rising or sinking, that's going to affect the local rate. It turns out if you're in Juneau, Alaska, sea level is dropping relative to land because Juneau is rebounding from having been covered by ice for thousands of years. So it's sort of like sitting on your mattress, you get up, it rises. Only it just happened, the mattress in Juneau takes 20,000 years. So here's sea level rising globally at 12 inches per century. Here's Alaska. So they're not worried about sea level rise in Alaska. They were about other things. If you're in New Orleans, however you pronounce it, there's sea level rising and the land is sinking. So New Orleans has really serious problems, and other areas as well. But that's what this uplifting subsidence means. So this is that long period again. This is from 1800 to 2100. This is that long period from 8,000 years ago to the present without a whole lot of change. This is what we've measured from tide gauges over roughly the last century or so, about the thickness of a dime per year, about 8 inches per century. One of the problems with all these tide gauges were they're stuck on land someplace. So if the land is rising or sinking, we've got to average out those all over the world. It turns out all the tide gauges weren't necessarily geographically evenly distributed. We have a lot of them in the U.S., not many in the southern hemisphere. We don't know which are rising and which are sinking. So this is the average. Beginning in 1993, we launched a couple of satellites that measure sea level from space, down to tenths of a millimeter. Now this is a nice age group. They're not high school kids. Nobody's listening to their iPhone. So you probably have similar technological background as I do. I do not understand an iPhone. That you could all be sitting in here and get on your phone, don't do that, and be talking to somebody somewhere in the world. There's no wires or nothing, it's just going out there. How does that work? I think it's amazing. I say that to a group of students in a class and they go, well, duh, it just worked. They say, how lame. I used the word dorky the other day in class, and I said, we don't use dorky. I said, what do you use? He said, lame, so I'm using lame. Anyway, we launched these satellites. We know where they are to a very, very high degree of accuracy. That's how we can get the space shuttle up there and link up with, space stations and stuff. Although I saw gravity for the night, they didn't do so well. Anyway, we launched these satellites, and we discovered since they were launched 20-some years ago that rate is actually almost double. And we're still kind of determined, is this typical? But it looks like that number is probably going to be going up. So we've been trying to project into the future to roughly 2100. I don't know why we picked 2100, from 2000 to 2100, 100 years. And there's a couple of ways to try to extrapolate into the future. It doesn't change too much for the next 10, 15 years, but then these are huge uncertainties. In fact, very huge. It could be 15, 18 inches higher by 2100. It could be 4.5 feet higher. Well, if you're living at 3 feet above sea level, that's a big uncertainty. And these come from both physical, I should say, mathematical models. And there's probably dozens and dozens of those. We model everything today. And I will say, that one of my colleagues who works with models, said models are models, they're all wrong. But hopefully they tell us something about the relationships between different parameters. If carbon dioxide doubles, based on the past history of carbon dioxide, this is how much we should see. And we can do empirical sort of calculations. If we go back into geologic time and say if greenhouse gases were this or the world temperature was this, here's how high sea level would be. So that's why there's a big range. But the uncertainties come from things like how much carbon dioxide is going to be in the atmosphere in 2100? Well, that's going to be dependent on how much more coal we burn, how many cars China buys, how many of us buy Priuses, how many of us have solar panels. Those aren't things we know. Those are social and political issues, not just science issues. So if you give us the number, we can figure it out. But that's why there's such a big range of uncertainty. So I turned to one of my favorite climatologists. Well, I'll come back to that. So some of the uncertainties, if we melted all the mountain glaciers on the planet, in the Alps, the Andes, Patagonia, we could raise sea level about 2 feet. That's not a lot of ice. If we melted all of Greenland, and Greenland's got signs of melting faster than we thought, we could add about 22 more feet to sea level. That would get close to the top of the bluff here. And then there's the 800-pound drill in the room, and that's Antarctica. And if we melt Antarctica, there's 200 feet of sea level equivalent. So if we put all those together, we could raise sea level around 225 feet. We're underwater, Santa Cruz underwater, New York's underwater, San Francisco, Shanghai, Hong Kong, Jakarta. Most of the world's big cities go underwater. How do you put one country? How do we turn this thing off? That's a real difficult question. So,
He was worried about showing you this.
And that's
He was
right
part of
there,
it.
but you-
I don't know who this was. I just asked my wife to pick a person for scale. So, a couple years ago, the National Academy was asked to do a study of sea level along the West Coast, and as a way to try to portray that this was not in the National Academy report, we decided to take we were asked to do sea level rise at 2030, 2050, and 2100. And because of the uncertainties, to do a low and a medium and a high. So this is by 2030, which is only 14 years away, the low, it could go up another 2 inches. The midpoint's about 6 inches. The high would be about 12 inches. That's just 14 years away. By 2050, somewhere around 6 inches is the low. A foot would be the midpoint, and it could be as high as 2 feet. By our estimates in 2012, when we go to 2100, somewhere around 16 inches, 3 feet, and it could be 5.5 feet. So there's a lot of uncertainties here, but 3 feet or a meter is roughly what people have been sort of using, but every day a new study comes out and says, you know, Antarctica looks worse than we thought. Greenland's melting faster than we thought. So these are the numbers we used a couple of years ago, and they're going to have to be adjusted over time. But here's my favorite climatologist. So with climate and with other things, I don't know, weapons of mass destruction, we have the known knowns, the known unknowns, and the unknown unknowns. So one of the things I want to keep in mind here is we can focus all of our energy on sea level rise, and is it rising 3.2 millimeters per year or 3.4? We have some other things to keep in mind, which are short-term events like the last week, the last winter. So this is a tide gauge, the oldest in the country, from San Francisco, and it's out at the Golden Gate. So what this is doing, this goes back to 1855 to the present. This is sea level rising at the Golden Gate. The tide gauges are put in by NOAA. They were there for tidal ranges and ships, but it turns out they're great indicators or recorders of sea level rise. So over this period of time, sea level is rising at about 7.5 inches per 100 years. So if we take this out and it doesn't change, you can get an idea in the next 100 years it will go up another 7 inches. But it turns out that's increased globally up to a foot now. But in the middle of this sort of long-term pattern are all these wiggles. Well, these are El Nino events. A big one in 1940 where sea level rose 11 inches during that several-month period. You probably, most of you remember the 82, 83 El Nino, the 97, 90. So almost a foot of rise over 2 or 3 months. So that's like 100 years of sea level. This is a short-term thing. And it turns out over the last couple of years it's gone up 6 inches. Not sure what that means. Sea level is higher in the western Pacific over by Japan and lower here, and there's got a wave coming back, so there's a lot of uncertainties. I just got this off the NOAA station for Monterey, and it turns out this is just the first couple of days of January because of this El Nino and storm surge. So this is the predicted tide, and this is the actual tide. So, whoops. This has gone up, it's been a foot above normal. It's got 100 years of sea level, which is why water's washing up all over beaches and shorelines. So these are the things on the short term we need to be concerned about. So in the big picture, sea level slowly rising, the bathtub's overflowing, but it's going to be these short-term extreme events. And see if you're watching. So we can look at long-term, and if we raise sea level 16 inches, which is sort of the mid-century number on average, this blue is all underwater. This is SFO. So it goes underwater at 16 inches of sea level rise. This is Oracle. It starts to get wet at 16 inches of sea level rise. That's serious stuff. And if you say, okay, well, I'm going to go to Oakland, Oakland's exactly the same elevation because they were built at a time of sea level wasn't an issue. They got it a couple feet above high tide and said, that's good. This is the Embarcadero where I started. A king tide. King tide is sort of, have you heard that word? So these are the extreme tides 2 or 3 times a year. We've got some coming in January. We had some in November, December. So this is lapping up on the Embarcadero a couple of years ago. This is just last November. This is out near Marin, Mill Valley. This is the Embarcadero. And this guy is so cool. It looks like Belushi. This is the Embarcadero again, splashing up on the sidewalk. This is Pacifica. There's always these people out here that I'll be doing a school project. And some of the other impacts of these short-term extreme events. So this isn't just the flooding, the elevating the water surface. This has been happening. This is down at Twin Lakes, very low lying. Aptos Seascape in the '83 winter, where water went up this revetment and blasted through the front of all those homes. That's a longer story. This is downtown Capitola. Water coming up over the seawall there into downtown. That happens not infrequently. And then Cliff Retreat, which affects the entire California coast. You may have seen pictures of Pacifica. These are probably history here. In fact, I was up there not long ago, and they're trying to protect these, and they're going to go. This is not granite. It has a really complicated geological term. It's called dirt. Seacliff, you may remember back in the 80s, 83 El Nino, people loved to park their RV here. And most of the year it looks pretty good, but in the 83 El Nino, that picture is taken right there. All the RVs are gone, and this bathroom was sort of trashed too. But these are logs that have been thrown over that wall. And the next point looked something like this. And we came back, the wall, a third of it was gone, it just been built. There's still the RVs hanging out there waiting for this time. The other thing that's happening in addition to slow sea level rise is waves seem to be getting larger, and that's a long-term project we have to kind of keep monitoring. But over roughly the last 20-some years, the average wave heights have gone up about 1.5 feet. The further we go north, the higher those waves seem to be getting, and the faster that's happening. Just to show you some idea of the retreat, most people probably know Depot Hill in Capitola. 1972, there was actually a house here, there was apartments here. You could drive along Grand Avenue. 2010, the house is gone, the apartments are gone, and you cannot drive along Grand Avenue. In fact, it's tough to walk along Grand Avenue. So this is retreating at about 1 foot per year. Pretty fast. Lives here. I got a call a couple years ago from a realtor. I don't remember your realtors, and said, I have an apartment complex for sale on Depot Hill. Do you think there's any problem? And I said, oh, is it the Antigua? And he said, oh, how do you know that? I know these things. So he said, do you think there's a problem? And I said, well, are you on a computer? And he said, yeah. I said, well, type in CaliforniaCoastline.org, because you may know this site that a couple in Watsonville, Ken Gabriel Edelman, got a lot of publicity because of Barbara Streisand suing them. But it has over 100,000 photographs of the California coast taken from the air, most of them from the helicopter, but also ones I had to go back in the 70s. So I got this up and said, well, put this number in. And all of a sudden I hear the phone drop. I'm sorry, I shouldn't say that. He had no idea. They were standing up here looking out to sea. He had no idea what it looked like underneath. And this stretch of coast is pervasively jointed. These are like cracks that run parallel to the coast. There's also another set of joints. And these big slabs keep falling off. I don't know what happened. I assume somebody owns it. But you can see the foundation getting undermined. And this is a case, you know, along a lot of places along the California coast. So this was just a week or so ago out in Westcliff. You know, is this climate change? It's just El Nino. I was watching people walking along here. A second before the lady out here with their dogs, and we were watching these waves. So how do we respond to all this? So we've really got 4 choices. We can ignore it. There's actually some states where they do that. You might have read about those. They tend to be in the south, in the southeast. They either outlaw sea level rise, that was on the Daily Show. or they forbid the use of the term sea level rise and they use coastal flooding or high tides. But we can ignore it at our peril. We can build floating cities. We have a few of those now, Sausalito. I think we're going to have a hard time putting the roughly 150 million people living within 3 feet of sea level on houseboats. I don't think we're going to be able to do that. We can build barriers, and that's been our sort of historic approach. More walls, more seawalls, more abutments. And that may be okay for certain facilities that are very high value and we want to protect. Maybe SFO, the nuclear plant at Fukushima. They didn't make it high enough. Or we can plan for managed retreat. I'll call that stepping back gracefully. How do we begin to retreat from those areas that are, have the highest risk? I kind of led you to the obvious answer. So this is the cover of an interesting book. So we may have enough time if we start right now. And if you had to summarize this in 4 two-word sentences, it's real, it's us, it's bad, scientists agree, there's some hope. The sun did used to be that there's hope, and I bet there's some hope. So I'll just leave you with some thoughts here that the way things are going in 5 years. Thank you, and I'm now going to turn it over to Mike.
All right. So as I pointed out, I'm a cultural anthropologist. And when I was director of the Duke Marine Lab, people would say, what's a cultural anthropologist doing? He's directing a marine lab. And the answer is that, as does Gary, I've always done a lot of work in conservation policy. Conservation is always, and environmental policy is always about human behavior. Studying biology or geology, no offense, Gary, isn't enough. You have to know about attitudes and culture and values and law and policy, because that's all we ever get to change, actually. So that's why I'm in this business. Now, the 2 major demographic forces in the world today are people moving to cities and people moving to coasts. This is going to create a very bad train wreck, because neither of these things are likely to stop soon, and it's all going to run into the kinds of things Gary has described to us. 30 of the largest cities in the world, they're mega cities, over 20 million metropolitan population. Of the 30 of them that exist, 20 of them are in low-lying coastal areas, and are very likely to be subject to the things that we're talking about, including places like Shanghai. Thousands, if not millions, of small cities, towns, villages, and populations, which will be low priority on public funding, for example, when this all starts to happen. Others, not even on the coast, that we don't think about. Houston, Texas, which is about an hour drive from the Gulf of Mexico, is in that low-lying coastal Texas plain and is only on average 2.5 feet above mean sea level, even though it's an hour away from the Gulf of Mexico. And billions of hectares of what I call natural infrastructure, fringe marshes, swamps, mangrove forests, that before people were here, when the sea level went up and down, as Gary has described it, they just went up and down with it. But now, we're in the way. And so we're going to have to worry about our natural infrastructure as all of this happens. Now, this is a new challenge because in the period of what I call modern human history, say the last 6,000 or 8,000 years, this has never happened to us in modern history. In particular, and Gary showed you this diagram here, in this last 6,000 or 8,000 years, when people have been building cities and coastal infrastructure, there hasn't been sea level rise. And there are 2 artifacts of this. One is that we've built all our infrastructure in a period where what's going to be happening now didn't happen and wasn't happening. And all of our law and policy was developed in this period. Roman civil law, English common law, all developed in the period when sea level wasn't rising. All of our law and policy, including our public trust law, whose is it? When you live at the coast, for example, is it public trust water, is it private land? All of that law and policy was developed on the assumption that sea level is going to stay the same, and it is not going to stay the same. So some evolution of our law and policy is going to happen. We'll talk about that more in a bit. As Gary said, that's the present rate, and every time you get into information, it goes up faster. Now, Gary glancingly referred to this, but I want to imprint this on everyone. When I say mitigation, I mean, can we stop something from happening that we don't want to happen? When I say adaptation, I mean, we're going to have to adapt to something that's going to happen. Even if we start acting like Al Gore wants us to, right now, sea level is still going to rise between 1 meter and 2 meters in the next 100 years. We cannot stop sea level rise between 1 meter and 2 meters. Because the system's too big, the scales are too long, it started too long ago, the effects we're talking about. This will happen. There's no doubt that it will happen. There's uncertainty about how fast it will happen, but there's no doubt that it will happen, and we cannot stop this. Now I'll add that, most likely, it's not going to stop at 2 meters. And here's an example of what happens if it doesn't. Now here is South San Francisco Bay at 1 meter. See all the area, the airport up here is where Gary was referring to earlier. There's how many of you have been to Waikiki Beach in Hawaii? All right, here's Waikiki Beach. Here's the Alawai Canal here. University of Hawaii is up here. This is the area that will be flooded. We got this from Honolulu's mayor, Jeremy Harris, with 1 meter of sea level rise. All of Waikiki is underwater. This is South Florida. Miami's here, Key West is here, Tampa, St. Pete up here. Lake Okeechobee is right here. All the red is underwater at 4 meters, which will happen sometime in the next couple of years. This is where? New York City at 4 meters, which will happen. It won't happen probably in the century, but it may happen in the next 2 or 3 centuries. The period equivalent to when we started the country. You may recognize where this is, upper left here. You get a hint here. St. Mark's Square in Venice. It was not designed to have this characteristic. Right? Now the problem with Venice is that the land is sinking largely because of overdraw aquifers with water, and at the same time sea level is rising. Now here we get to some of the solutions people start thinking of to this. This is a gate system called the Mose system, and they're planning it, so these are hollow tanks that when you fill them with water, lay down in this ditch, and when you blow the water out, they come up. And here's Venice Lagoon. It's about a third the size of San Francisco Bay, about 50 kilometers long. Here's Venice right at the top. They're going to literally try to stop the tide from coming in Venice Lagoon. Now this may or may not, by the way, it's a $6 billion project. Concerning which the mayor of Venice has just been arrested for corruption. But anyway, this is Italy, right? Okay, anyway. So this is their solution. They're going to try to stop the sea from rising on high tides in Venice Lagoon. I gave a talk with one of the engineers, the chief engineer of the project, and I asked him, I said, did you guys take into account sea level rise when you designed this? And he said, well, you got to remember, we started this in the 80s. He said, frankly, no. But when we back calculate, we think it'll work up to about 1 meter. Now, think it'll work, it's an interesting phrase. We're just spending $6 billion. And by the way, it's about 5 years behind schedule. It should be online in 2017 or 18. We'll see what happens. But the thing that is interesting about this is that one of the things you have to keep in mind is when sea level rises, you know what the water table is? You know, when you dig down and you do what? the water table rises also. So even if you put down a big fence or a dike, the water is going to rise behind it eventually because of the water table rising as well. This is the famous example of defense. This is the Netherlands. Here's Netherlands right here, Belgium here, Germany here. Their famous coastal defense system you see in red here, built largely courtesy of our Marshall Plan after the Second War. Here's one of the barriers that has gates that slide up and down, and they do in fact have, for the better part of 50 years now, stopped tides and flooding in the Netherlands. This is the town of Emden, which is right here. It's where all the Volkswagen shipped from Germany to the US. It's a port town, and because of the old defenses they built up over thousands of years, the port of Emden here, you see it here and here, is 5 meters higher than the Baltic Sea outside of it. And there's a series of locks that carry the ships up. Now, the artifact of this is, because of the history of defending themselves from the nasty Frisians who kept attacking them from the west, they're pretty well set for sea level rise, but they're a very unusual case. I'll get back to the Netherlands at the end of the talk. Now here is New Orleans. And the unique feature of New Orleans is, over time, largely because of trying to make the Mississippi River straighter and more reliable for shipping, what's happened is there's a very extensive diking system that's been built, and New Orleans, here's the city of New Orleans, is in this situation. Here is Lake Pontchartrain here, and here is the Mississippi River here. New Orleans is on average 2 meters below sea level, and has been ever since its modern development, that is with the channelization of the Mississippi River. This is a problem, as we saw in Katrina here. But it's an amazing system, because if you drive down south of Louisiana, I'll show you that just in a minute, you drive on a road here, and here's the dike here out in the rural area here. You drive along this road, it goes south from Nolens. You will see this dike here, but then you'll see a 600-foot freighter going by 30 feet above you. Now that gives you a hint that the landscape's been altered a bit, right? Now that's helped many places in the past. It's actually going to be a big problem for us in the future. Here's South Louisiana. So here's New Orleans. I'm actually on a committee right now. Been asked by the governor to be on a committee to oversee the development of the next Louisiana Coastal Master Plan. And we are trying to help them think about what they're going to do about this. And this is South Louisiana here. The red is 1 foot of sea level rise, will be underwater. The brown is 2 feet, and the yellow is 3 feet. Some of the largest oil infrastructure in the Gulf of Mexico is right about here, called Port Sulphur. Right? This also is a problem. Now, sometimes, well, most often because of political factors, sea level rise discussions tend to get lumped into the storm hazard discussion. It's like a storm, right? No. Why isn't that like a storm? Because storms come and go. Sea level rise is forever for all practical purposes. Even if we talk about the 100,000-year cycles that Gary talked about, in terms of human infrastructure and law and policy, it is forever when it happens now, right now, to us. Permanent change of state. All right, you've seen a couple of these pictures already. This is Santa Cruz, the Twin Lakes, as Gary pointed out recently. This is Capitola here. This is Balboa Island, California, where I grew up when I was a kid, Newport Beach. Nice place, it's a bulkheaded dredged island in Newport Harbor. This is the ferry that goes over to the peninsula, the Gulf Peninsula here. This is at one of the normal high tides on the west coast, that is the king tides on the west coast. This is the bulkhead. There's a nice walkway that walks all around Balboa Island. This is about 2 feet, 2.5 feet above the walkway here. And the high tides routinely top over this bulkhead. What you see here is the street. The street level is about 3 feet below the top of this bulkhead here, which is overtop the high tides. What you see here, this white water, is the tide coming up from the storm drain. So in fact, what happens now is the streets of Balboa Island fill through the backfill through their storm drains on king tides. Now let's bring this all home to Santa Cruz. This is the FEMA map, flood map, of Santa Cruz. So here is the police department, here's the city hall. So this is the downtown area of Santa Cruz. The blue is the 100-year floodplain. Does anybody know what the assumption is about how high the 100-year flood would be for this calculation? They know what it is.
5.5 feet?
2.6. 2.6. This is calculated on a 100-year flood above mean high tide, not king tide, mean high tide of 2.5 feet. Between 50 and 100 years from now, this isn't going to be the 100-year floodplain. This is going to be underwater all of the time. So go on your computer and Google 100-year floodplain for Santa Cruz, and you will see the future of Santa Cruz in 50, probably my guess is 70 years, 75 years. Okay. Here again is San Francisco. That's the airport. Gary's already showed you that. Now, this is an especially difficult challenge for several reasons. One, although the direction is clear, the timing is uncertain. Although, as Gary says, above the estimates we have now, every time we get new and better information, the estimate goes up for sea level rise. Second, and this is the big problem, that all this is beyond any political cycle. No one who is elected today or is going to be elected in the next 10 years is going to be in office, especially if you're a local official, when this really starts to get bad. So nobody has an incentive to do anything about it now, politically. Okay? We've never faced this challenge before. Remember the flat part of the graph up there for the last 4,000 years? This is new stuff for us. We're going to have to figure it all out. We lack law and policy tools. For example, one of the interesting questions, something called public trust law, talks about where public property ends, we're called navigable waters, and where private property starts, which is where, if you're a riparian homeowner on the water, where your land stops. Every state is different in defining where that happens. There are some states that are mean high water states, you own above the mean high tide line. There are states that are mean low water states, you own only above all the way down to the mean low water mark. There are some states like Georgia who allow private ownership of land below mean high tide. Very few, but there are some, mostly for oysters in Georgia, with their 90-mile coast, which is very small. The interesting part of this is, when sea level rise and it starts to inundate things, what happens to the ownership and the use rights of that property? And every state is different. Generally, when things get inundated permanently, it goes to state ownership, but not always. Actually, the most advanced state on this law is Texas, which says, and it's something called the Open Beaches Act, that all property that is permanently inundated automatically becomes property of the state. In most states, it has to be litigated one way or the other. In Florida, it doesn't happen that way because the private property rights movement is so strong that any time the government wants to take ownership, essentially, of an inundated piece of property, they have to sue in court for that to happen, and the courts are not hearing this in Florida these days. So in Florida, it's a serious problem because the private property rights movement is not allowing any change of state to occur. The philosophy, and there's a group called the Pacific Legal Foundation that espouses this, that says that when you buy property and your land is surveyed, no matter whether it's fully inundated or not, i.e. underwater, you still own all of that property. Right? Now that's kind of an outlier position right now, but who knows? Law and policy change all the time. And that's, again, the thing. We don't know what we're going to do about all of this. And of course, some people do not believe any of this. I hope there's some of you here we can talk about this. Now, my conclusions. We will not defend all of our low-lying coastal areas. It will not be engineering or economically feasible to do it. No matter whether we defend or not, we should immediately begin planning for where we're going to move our infrastructure, not if but when this happens. Now that's a problem, because what time frame do you plan on? 100 years, 200 years, 300 years? When you have to move New York City, where do you move it? Alberta. And provision for dealing with inundated, abandoned infrastructure. I predict this will be the biggest problem. When San Francisco Airport's underwater, what do we do with it? When downtown Santa Cruz is underwater, what do we do with it? Become recreational condo diving? And we should immediately be planning for provision of allowing open space for our natural areas, such as estuary habitats, to move when they migrate, or else we're not going to have any coastal productivity. Now, going back to the Netherlands, most defended country in the world. They have a new policy, their new 10-year plan. It's called Living with Water. So this is a statement. This is the ambassador from the Netherlands introducing this at the United Nations. Our old dikes approach is no longer sustainable. We're learning to adapt to live with water. That's the name of their new paradigm. And they are planning to essentially abandon up to 20% of their current protected area in the Netherlands. They understand this problem, and they're thinking about it in a careful and forward-thinking way. Thank you very much. Questions, comments? We have a little bit of time. Yes, sir.
So what is the thinking about New Orleans, and who will pay for protecting it if that's the plan?
Well, New Orleans is a special case because it is the port that serves the Mississippi River ship traffic, which is so much material coming out of the whole Mississippi Valley, which is central third of essentially the United States. So my guess is that with federal funding, that port of New Orleans will be protected. My guess is also that almost everything that was colored in that South Louisiana slide will essentially be abandoned. And in fact, at the last meeting of the committee I was on, I talked about the Coastal Restoration Authority had just abandoned plans for a new diversion of the river to try to build wetlands south of Louisiana, because they said to the state, and the legislature bought this, it's going to be underwater. Why are we going to do this thing? So that will all be abandoned. The port itself, because it's so close to the river, and the river extension in the Gulf, so-called Bird's Foot, will be maintained largely by the federal government. And by the way, so this is, as soon as this starts happening, you will hear a huge sucking sound of money going to big cities and coastal ports. You come into Santa Cruz.
Just follow up, so the parts of New Orleans that were flooded in Katrina, are they being rebuilt right now? Are there areas there that should just be left on?
That's a very good question. And the answer is, the question is, the areas that were inundated during Katrina in New Orleans, are they being rebuilt? What's happening with them? And the answer is that there will actually, that most of them are being rebuilt or redefended, because it's looked at as a failure of the dike system because of this, which largely is true. But there was a move to take certain areas, you might have heard the lower Ninth Ward, and simply buy people out, because we realize it's going to happen again at some point. That, all of those measures in the state of New Orleans, or in the state of New Orleans, failed politically. And so people still own their land, because they should do not accept it. Yes, ma'am.
In Santa Cruz, we're building a lot of, or planning to build a lot of more affordable units in areas that are in floodplains. Is this something that is it seems like it's not a best investment, other than the fact that we just need housing so badly?
You know, I gave this talk like this in Sarasota, Florida, very low-lying area, and was asked by a county commissioner afterwards, all right, Mike, you're so smart, what are you going to do when making the king of Sarasota? And I said, well, okay, the first thing I do when I come to work Monday morning, no new permits for any new construction below the 5-foot contour above mean sea level. Below mean sea level. No, the mean high tide. just don't stop. Stop it. We're just, it's going to be not supportable in just a few decades. Just stop it. No. Now this, of course, brings up a big problem with eminent domain and how the government needs to deal with private property. Yes, in fact.
Yeah, thinking long term, I read a report that because of the shift of ice down into the Atlantic, shoving the river current south, that's going to impose an ice age in Europe. I don't know when, 1,000 years from now. Any comments?
Gary, why don't you take that?
What was the report?
The report said that because of the melting ice and the cooling of the water from the Arctic, it would shove the Bermuda current south that normally sweeps up, as you know, and warms England and continental Europe. That's going to impose an ice age on England, continental Europe at some point. 1,000 years, I don't know.
Did everybody hear the question?
Yeah.
I think there's a big difference between shifting ocean circulation, and it's clear that the Gulf Stream, which starts in the Straits of Florida and goes out around Cape Hatteras, warms up the North Atlantic, so that it's hard to believe, but Spain, which we think of as fairly warm, is actually the same latitude as Maine. England is Labrador, so it's much warmer than you would expect at that latitude. So we can lower those temperatures with changing circulation, but that's a lot different than bringing on an ice age, which takes a whole lot of heat loss, and we're actually going the other way. So projecting out very far into the future about an ice age because of the shift in that circulation, I would say, is not in the cards.
Yeah, I'll also say that if you look at climate change generally and sea surface temperature, atmospheric temperature, what you see over time is that the trend is up, but the line is jagged. So when people say, oh, we're having a cold winter, therefore there's no global warming, it just means we're in a jag. Right? You have to look at the trend line. Yes, ma'am.
Yeah, you took it off the screen, but on the map that you showed of downtown Santa Cruz, I don't know if you're familiar with where our wastewater treatment plant is.
Oh, yeah.
But it's in Erie Lagoon. Is it within that blue area?
Right on the edge of that blue area. Yeah.
So,
Yeah, because as you know, there's a flat area and then there's a big bluff right there where the bike trail goes.
Exactly.
Yeah, so it's in the city.
So I guess one question to the city of Santa Cruz is should they begin to think about moving that wastewater treatment plant somewhere else?
Do you hear the question about moving the wastewater treatment plant? That's a really interesting question. The question is, when do you have to start this stuff? You know, how far ahead of time do you really want to, how far ahead of the curve do you want to get on this? That's a very interesting question. My guess is, unfortunately, we're going to end up behind the curve because people aren't going to want to move and spend a lot of money until somebody's water's up to their knees somewhere.
If I can add a little bit to that. So I guess 3 years ago we did a study for the city of Santa Cruz. It was called Climate Change Vulnerability Assessment. So it was looking at all the ways in which the city of Santa Cruz is vulnerable to climate change. And one of the groups I talked to were the people that run the sewage treatment plant, because right now all of the sewage treatment plant and all of downtown Santa Cruz is on the floodplain of the San Lorenzo River. And the early settlers did not move down there. It wasn't until the gold rush that they started creeping down by the town clock. And so we know that's floodplain. That shouldn't be a big secret. When somebody asked about more building down there, you know, there's some good long-term questions. But they said, you know, we already have problems. So when there's a high tide, most of the businesses downtown used to have basements. And they all had sump pumps. Because when the tide came in, they'd have to pump water out back into the river. After the earthquake, most of those were destroyed. But we now, some of the city parking lots pump 24 hours a day back into the river because of the high water table. So right now they're big tanks. In a really high tide, they actually open the valves on the bottom so they don't float out of the ground. It seems odd. You could float a swimming pool out of the ground if it was, you know, high enough water table. So they said, you know, we should be thinking now about relocating the sewage treatment plant. I mean, we just rebuilt it at $100 million over the last X years. The problem is you want it in the lowest place in town because things flow downhill. So it's a huge issue. But I think a larger answer, whether it's the sewage treatment plant or Rio Del Mar, Aptos, Seascape, that whole area has their sewage trunk line under the beach. The houses that are Potbelly, Villa Gaviota, so forth, their sewage runs under the beach. So as soon as sea level rise, and during a big storm, you can see the manholes exposed. So the question for any structure, whether it's San Francisco Airport or new housing downtown, is say, what's the sea level rise rate at that location? And it's again different in New Orleans and Juneau or Santa Cruz. What's the cost or the value of the facility? What's its lifespan? And what's the cost of it being damaged or destroyed? So if it's a parking lot, let's just say it's, picnic tables at natural bridges. We don't need to worry too much about that. Is it a bike trail? Is it a, bathroom? Seacliff, the state park. We can use that for a while. But if we're going to build a new sewage treatment plant, a power plant, an airport, those are huge facilities, billions of dollars. I think we want to think really carefully. Is this a 100-year facility? We better look out 100 years and a lot of margin.
What are you going to have time? We take a couple more questions?
It looks
Facility
like,
people, how are we
it looks
doing?
like we should call time, actually, and people can, maybe one more question, and then people can speak to you after the program.
Okay, well, we can. Okay, let's take one more question.
Well, I'm in California, so I do not understand if your property is permanently inundated, what value it has to why you would want that.
Well, one of the interesting questions is, if you own the bottom, what happens to the water column above it? Because one aspect of that is valuable things can happen in that water column. You have control of the water column. And the next argument the Pacific Legal Foundation is going to make is, if they own the water column, they also have rights to the bottom, they also have rights to the water column. That's a complicated legal question. Yeah, but we can talk afterwards. Let me just close by saying, a couple of years ago, a reporter from the New York Times called me to talk about this, and she said, after hearing all of this, she said, "Look, isn't this an opportunity to rebuild our coastal infrastructure in a new and more sustainable way?" And I said, yes, it is, if we look at it that way. Thank you very much.
And great to see so many people on a Sunday afternoon. Wonderful.
All right, one more announcement from program chair.
Hi, I'm Judy Orbach. For any of you who are not Seymour Center members or League of Women Voter members, we have some flyers and material on this table over here. So stick around and pick up.
And you have program material over there.
Yes.
For future events.
Yes, well, the upcoming events for our organization and probably for the Seymour Labs. Thank you.